The cognitive cost of AI assistance, protecting human thinking in the age of generative AI abstract. Recent research reveals concerning patterns in how artificial intelligence tools may be affecting human cognitive processes. This paper examines emerging evidence demonstrating potential reductions in cognitive engagement when individuals rely on generative AI tools for knowledge work. The findings suggest implications for organizational creativity, problem-solving capability, and cognitive resilience. Drawing on both empirical research and established cognitive science principles. This paper outlines evidence-based approaches for mitigating potential negative effects, including structured AI usage protocols, cognitive protection practices, and hybrid thinking methodologies. Organizations implementing these approaches are better positioned to leverage AI's efficiency benefits while preserving the distinctive human cognitive capabilities that drive innovation and complex decision-making. Artificial intelligence tools have rapidly transformed knowledge work across industries, with generative AI adoption accelerating at unprecedented rates. McKinsey estimates that generative AI could add between 2.6 trillion to 6 trillion to 6 trillion to 4 trillion annually to the global economy, Chue et al. 2023. Organizations have embraced these technologies for their remarkable efficiency benefits, from rapid content creation to code generation and decision support. Yet beneath this wave of productivity gains lies an emerging concern: these same tools may be fundamentally altering how humans think. While research specifically on the neurological effects of AI tool usage is still developing, established cognitive science principles regarding cognitive offloading, attention, and skill development provide a foundation for understanding potential impacts. These findings suggest that what appears to be a straightforward technological augmentation may carry hidden costs for the very thinking capabilities that drive organizational innovation, complex problem-solving, and creative differentiation. This paper examines the potential cognitive impact of AI tools, their organizational implications, and most importantly, the evidence-based practices organizations can implement to harness AI's benefits while protecting their most valuable asset, human thinking capacity. The cognitive impact landscape defining cognitive processing in the AI context. Cognitive processing refers to the mental activities through which humans acquire, process, store, and use information. These processes include attention, perception, memory, language processing, problem-solving, and creative thinking. Anderson, 2015. When we interact with technology, these cognitive processes can be augmented, altered, or in some cases, diminished through what cognitive scientists call cognitive offloading, the use of external tools to reduce cognitive demands. Risco and Gilbert, 2016. In the context of AI assistance, cognitive offloading becomes particularly significant. Unlike previous technologies that primarily offloaded memory or calculation, generative AI can offload complex cognitive processes including language formulation, idea generation, and even aspects of critical thinking. This higher-order cognitive offloading presents both opportunities and potential concerns for human cognitive development and maintenance. Current understanding and research findings, while comprehensive neurological studies specifically examining AI's effects are still emerging. Established research on cognitive offloading and technology use offers relevant insights. Research on cognitive offloading demonstrates that when people rely on external tools, including technology, they typically show reduced memory encoding and recall for information they expect to be able to access later, a phenomenon known as the Google effect. Sparrow et al. 2011. This effect represents a rational reallocation of cognitive resources but can lead to reduced knowledge retention and potentially weaker conceptual integration. Studies examining the effects of automated systems on human cognition have found that as automation reliability increases, Human operators' situation awareness and engagement often decrease, a phenomenon termed automation complacency, Parajureman and Manzi. 2010. This reduced engagement can impair performance when the automated system fails or encounters novel situations. The prevalence of AI tools in knowledge work makes these findings particularly relevant. A 2023 survey found that approximately 35% of knowledge workers report using AI tools in their work. With adoption accelerating rapidly, Pew Research Center. 2023. This rapid adoption is driven by several factors: organizational pressure for efficiency and productivity, competitive pressure to adopt emerging technologies, convenience and reduced cognitive effort, the engaging conversational nature of modern AI interfaces, the potential for both short-term productivity gains and longer-term cognitive impacts creates a complex landscape that organizations must navigate thoughtfully. Organizational and individual consequences of AI-induced cognitive changes. Organizational performance impacts. The immediate productivity gains from AI adoption are increasingly well documented. For example, a study by Noe and John, 2023, found that professionals using AI assistants completed writing tasks 40% faster with higher quality outcomes than those working without AI. However, cognitive science principles suggest potential longer-term organizational costs that may offset these gains if AI is implemented without consideration for cognitive impacts. Research on expertise development indicates that deep knowledge and skill acquisition require effortful practice and engagement. Erickson and Poole. 2016. If AI tools substantially reduce the cognitive effort required in knowledge work, this could potentially affect the development of deep expertise within organizations, particularly for newer employees who may never develop certain cognitive capabilities that were previously cultivated through experience. Furthermore, creativity research suggests that novel idea generation often emerges from the recombination of deeply encoded knowledge and experiences. Beatty et al. 2014. If AI tools reduce deep engagement with information, this could potentially affect organizational innovation capabilities over time. These findings suggest that while AI can dramatically enhance performance in predictable domains, uncritical implementation may simultaneously undermine capabilities critical for differentiation and adaptation. Individual well-being and professional development impacts beyond organizational performance. Cognitive changes associated with technology dependency carry implications for individual development and well-being. Research on skill acquisition demonstrates that skills which are not regularly practiced tend to atrophy, a use it or lose it principle well established in cognitive science. Erickson et al. 1993. This raises questions about how cognitive capabilities might be affected if consistently offloaded to AI systems. Professional development typically involves progression from novice to expert through deliberate practice and the development of increasingly sophisticated mental models. Kai et al. 2014. If AI tools reduce the cognitive challenges that drive this development, career progression patterns may require rethinking. Studies on technology dependency show that excessive reliance on external tools can affect cognitive confidence, individuals' belief in their ability to perform without technological assistance. Ward. 2013. This has implications for professional identity and satisfaction, particularly in knowledge-intensive fields. These potential impacts suggest organizations should consider not just the immediate productivity benefits of AI tools, but also their effects on employee development, satisfaction, and cognitive resilience. Evidence-based organizational responses, structured AI usage protocols. Research on technology integration in knowledge work suggests that establishing clear protocols for when and how tools are used can significantly mitigate potential negative impacts while preserving benefits. Brynjolfsson and McAfee. 2017. Studies of human-automation interaction demonstrate that maintaining appropriate human involvement in automated processes helps preserve situation awareness and skill maintenance. Ensley. 2017. These findings suggest organizations should implement structured approaches to AI usage. Effective approaches include defining AI-appropriate vs. human primary tasks, delegate routine, formulaic tasks to AI, data summarization. Formatting, initial drafts, reserve strategic, novel, and high-stakes decisions for human primary thinking. Establish clear handoff points between AI and human workflows. Require documentation of AI use in work products. Research by Diet Vorstik et al. 2018 found that giving humans appropriate control over algorithmic processes improved both performance outcomes and user satisfaction. Their work suggests that establishing clear boundaries between AI-assisted and human-led tasks can optimize results while maintaining human agency and skill development. Cognitive protection practices drawing on research in attention restoration and cognitive performance. Organizations can implement practices that create dedicated spaces for unassisted human thinking. Kaplan and Berman. 2010. Studies of optimal performance indicate that alternating between periods of focused attention and recovery leads to better outcomes than continuous engagement. Erickson and Paul. 2016. Applied to AI usage, this suggests alternating between AI-assisted and unassisted work sessions may be beneficial. Effective approaches include time-based protections, designated AI-free work periods, mornings, specific days, regular, deep thinking sessions without technological assistance. Alternating AI-assisted and unassisted phases for projects. Cognitive recovery periods after intensive AI collaboration. Research by Newport, 2016, on deep work and cognitive performance demonstrates that creating protected spaces for focused cognitive engagement is essential for high-quality knowledge work. His findings suggest that organizations would benefit from establishing clear boundaries around when and how AI tools are used to preserve spaces for deep human cognition. Hybrid thinking methodologies. Rather than viewing AI use as binary, used vs. not used, cognitive science principles suggest that specific interaction patterns with tools can minimize downsides while maximizing benefits. Clark. 2008. Research on effective human-AI collaboration suggests that systems where humans and AI complement each other's capabilities produce better outcomes than either working alone. Kumar. 2016. This points toward the development of specific hybrid thinking methodologies. Effective approaches include start human, enhance with AI. Begin problem solving with unaided human thinking. Introduce AI after initial direction is established. Use AI to enhance rather than generate core ideas. Consciously evaluate and modify AI outputs. Critical engagement patterns require modification of AI outputs rather than direct use. Implement structured questioning of AI-generated content. Practice AI challenging, where teams identify flaws in AI reasoning. Alternate between AI suggestion and human critique. Research by Bansal et al. 2021, on complementary human-AI capabilities found that the most effective collaboration occurs when humans and AI systems contribute their distinctive strengths to a problem. Their work suggests that organizations should develop specific protocols for how humans engage with AI tools rather than treating AI as a simple replacement for human effort. Building long-term cognitive resilience. Metacognitive skill development. As AI becomes increasingly integrated into knowledge work, organizations must explicitly develop metacognitive skills, the ability to understand and regulate one's own thinking processes. Flavel. 1979. Research shows that individuals with strong metacognitive skills are better able to effectively use external resources without becoming dependent on them. Dunlosky and Metcalf. 2009. This suggests metacognitive development may be crucial for healthy AI integration. Key developmental areas include thinking pattern awareness, training to recognize when one is outsourcing thinking vs. engaging deeply. Decision ownership, practices that reinforce accountability for thinking processes. Not just outcomes. Cognitive process articulation, requiring explicit documentation of thinking steps. Not just conclusions. Thinking quality evaluation, Frameworks for assessing the quality of thinking independent of outcomes. Organizational learning systems. Organizations need systems that capture and distribute learning about effective human-AI collaboration patterns. Research on organizational learning suggests that structured reflection and knowledge-sharing processes are essential for adapting to technological change. Argote and Myron Spector. 2011. This indicates the need for dedicated learning systems around AI integration. Key components include AI interaction pattern libraries, documenting effective and problematic usage patterns, cross-functional cognitive communities, groups that share experiences across domains, regular reflection practices, structured assessment of AI's impact on thinking and work quality, cognitive impact metrics, measuring both productivity and thinking quality outcomes. Technology design and selection. Organizations can significantly influence cognitive impacts through thoughtful selection and configuration of AI tools. Human-computer interaction research demonstrates that interface design significantly affects how humans engage with and are affected by technology. Norman. 2013. This suggests organizations should carefully evaluate AI tools not just for functionality but for their cognitive implications. Key considerations include interface friction, intentionally maintaining appropriate effort barriers in AI interfaces, thinking prompts, selecting tools that encourage human reflection before providing solutions, transparency features, prioritizing tools that make their limitations and sources explicit, configurability, selecting tools that allow organization-specific usage parameters. Conclusion. While specific research on AI's cognitive impact continues to develop, established cognitive science principles provide a framework for understanding potential effects and developing appropriate responses. The rapid adoption of AI assistance presents organizations with both significant opportunities and important considerations. The evidence from cognitive science is clear. How we use our minds shapes their capabilities. Cognitive offloading, while efficient in the short term, can potentially affect skill development, knowledge retention, and creative capacity if implemented without thoughtful guardrails. Organizations implementing structured usage protocols, cognitive protection practices, and hybrid thinking methodologies demonstrate that it's possible to capture AI's remarkable efficiency benefits while preserving human cognitive capabilities. As AI capabilities continue to advance, the truly strategic advantage may not come from having superior AI tools, but from superior approaches to integrating these tools with human thinking. Organizations that develop this integration capability, preserving human cognitive strengths while leveraging AI's computational power, will likely outperform those pursuing either extreme human centricity or uncritical AI adoption. The evidence suggests a clear direction. Successful organizations will be those that use AI not as a replacement for human thinking, but as a catalyst for enhanced human cognitive performance.